Hello electronics class, I wanted to give you some help on homework number 3. Here are some brief notes to help you get started. On problem number 1, you can just look in section 3.1, so you can just jot this down and refer to this later on. And in problem number 2, what you can do on this one is use equation 3.3. On problem number 3, you can use equation 3.1. And down here on problem number 4, although the current does not always behave this way, when they use the word steady, what they're meaning is that the current is equal to the total charge over time. So I think you're looking for the time in this case, so you just solve for that. And you'll need to use this equation and also equation 3.1. So this is not equation 3.1. There's another equation in the chapter that will help you there. On problem number 5, you want to use the rules for series and parallel combinations of capacitors, and refer to figures 3.9 and 3.10. The rules here, the equations, are pretty much opposite of what you see or what we saw for resistors in series and parallel. So capacitors, the equivalent capacitance is the sum of the reciprocals, reciprocaled, if that is a word. And then for parallel, you just add up the capacitances of those. We'll explain why that is a little bit later. On the second page. By the way, on these two problems, if you're using the 4th edition, it's I made a typo again, so 3.25b if you're using the 4th edition, and here's the 3rd edition. You're going to use those same series and parallel equations that we saw on the previous page for capacitors. On problem number 7, this is going to be for inductors. Just refer to the narrative that you see in section 3.4, and then for the series and parallel configurations, you want to see figure 3.20, and it goes back to being like a resistor again. So in the case of series, you add them up for inductors, so L is the inductance. And parallel inductors, you have the reciprocal of the sum of the reciprocals. I said it right this time. And then down here you're doing the same thing but for a different network. Okay, let me go through just a few capacitor networks. For this one right here, what you would do is you would combine these in series first. Now remember, this is going to be the reciprocal of the sum of the reciprocals for that, because they're in series, opposite of what the resistors gave us. And then after you have that combined, you want to combine these in parallel, which basically means you take the capacitance here and add it to the capacitance that you have for that series network. You'll see what I mean once you write it down. And again, what you do on these is you kind of start on the outside and work your way back toward the terminals. So series would be in parallel with this one, and then the combination of those three would be in series with this one, and then the combination of all of those would be in parallel with that one. Going down to one of our homework problems, you would say these are in parallel first, you'd say these are in series, and then you do that step first, and then you say that's in parallel with this one. And then I guess what you would need to do is, after you combine these parallel, you'll need to combine these series, and then you'll see that this side is in parallel with that side over there. So do it step by step. Make sure you don't skip any steps, and it'll make it a lot easier in finding the solution to this problem. This one's a little bit tricky. What you'll need to do is basically just pull those two nodes, those two junctions together, and kind of eliminate that wire, and you'll see that these two are in parallel, those two in parallel, and once you combine those two, you'll find that you have two equivalent resistors in equivalent capacitors rather in series. Moving on to examples involving inductors, you simply add the values of inductances. These are measured in henries, by the way. You add them up if they're in series, and then you get a total right here, and then you do the reciprocal of this plus the reciprocal of that, take the reciprocal of that, and then you get an equivalent inductor here, and then you add that to this one over here. A little more complicated, but first combine those in parallel, those in parallel, and then you'll have an equivalent inductor there. They would be in series. Combine those two, and then all four of these would make one inductor, which would be in parallel with this one, working your way from the outside in. I'm not sure if this is one of the problems on the homework or not, this bottom one, but parallel, parallel, series with those two, series with those two combined. And I guess then you would get these, an equivalent inductance for those three, an equivalent inductance for those three, which would be in parallel, this group in parallel with that group, and then combine that, and that's an in turn in series with this one. This one is another tricky one because they kind of put a short circuit in here from there over there, which basically eliminates the effect of this one and this one. So current would come in here and take the path of least resistance, or in this case no resistance, and so it looks like this inductor, that inductor, and that one have no effect in the inductance of this circuit due to the short.